right, well, thanks so much for the opportunity to present. I'll be sharing at a high level what we've been working on in our project, which is called Developing Models for Simulating Phosphorus Flows at the TBLs. But we sort of internally call it the TBL Modeling and Monitoring Team because what we do, I think, is more expansive than what that title would suggest.
You have seen the aquatic, urban, and agricultural TBL sites, each one offering a unique ecosystem for understanding phosphorus flow and sustainability. But the real power of these sites lies not just in what we learn within them, but in what we learn across them. Cross-site connections let researchers explore the similarities and differences in phosphorus flow and management within these ecosystems. One example of cross-site connection started when our researchers started developing hydrologic models and combining them with stable isotopes at the agricultural TBL site to track phosphorus transport and flow. Once those models and protocols were working, they expanded them to the urban and aquatic TBL site, scaling up the insights and testing them in different environments. That's a classic cross-site success story. Another example started with the aquatic TBL site, where researchers work with management agencies to co-create maps to define priority areas of concern. This kind of stakeholder engagement is now a model for how we integrate community voices across all TBL sites. And that's because TBL sites aren't just for research. They're what we call boundary objects. That means they are shared spaces where multiple disciplines, perspectives, and even sectors can collaborate in real-world settings. What are the broader impacts of the TBL sites? Let's break it down. In terms of education, these sites help researchers see how their work fits into the big picture. And also, students get hands-on and in-situ learning. Another type of impact is on stakeholder networks. TBL sites help to reveal new research directions and make science more inclusive and relevant. Of course, it is not without its challenges. When you do comparative case studies across such different ecosystems, things get messy. You can always generalize findings the way you could with controlled lab experiments. Sometimes you run into equifinality. That's when multiple paths lead to the same outcome. For example, one site might improve phosphorus efficiency by optimizing crop rotations, while another does it by recovering nutrients from wastewater. Same goal, completely different approach. And while the current 3 TBL sites are powerful, they don't capture everything. There's still room to grow. The STEP Center is evaluating new sites to add to the TBL network, places that would introduce new ecosystem types or fill in the gaps in the phosphorus puzzle. But any new site must bring something in common and something new, helping build a more complete spectrum of real-world phosphorus challenges and opportunities. Today's weak problems, like phosphorus sustainability, demand more than isolated projects. They require tools that support transdisciplinary collaboration across perspectives, geographies, and expertise. That's exactly what TBL sites provide. A shared space to develop common language, pool resources, connect disciplines, and engage with communities. Whether aquatic, urban, or agricultural, each TBL site plays a unique role. Together, they strengthen research organizations like ours, enable real collaboration between projects, link phosphorus sustainability to bigger sustainability goals, and most importantly, they create a space for innovation to take root, grow, and spread. Welcome to the future of phosphorus research. connected, collaborative, and grounded in the real world.